All right, chemistry folks. In this video, I'm going to go through some very specific examples of how to answer questions using the solubility curve. After I demo how to find the answer for each question, you need to answer the multiple choice question that follows. It's the exact same question. You must answer 9 out of 12 correctly to get full credit for the assignment. First, a few general comments. This graph has a bunch of lines on it, so at first glance it might seem overwhelming. But rather than give you 12 different graphs and you have to figure out which graph to look at, we put all the information on a single graph. So for 99% of questions, you're going to be looking at a single line that relates to a single chemical. The line for each chemical, NaNO3, KNO3, represents how many grams of that particular solute can be dissolved in 100 grams of water at various temperatures. So if I say, what is the solubility of NaNO3? How much NaNO3 can I dissolve? How much does it take to make a saturated solution? All of those are answered by saying, here's the temperature, here's the amount. We can also use the graph to answer questions about what type of solution do I have, saturated, unsaturated, supersaturated. So I'm going to go through these 12 specific examples. Question number 1. What is the solubility of KNO3 in 100 grams of water at 40 degrees C? Now, on a few of these questions, I have specifically said in 100 grams of water. But if I don't say anything, the assumption is it's 100 grams of water. So what is the solubility, KNO3, 100 grams of water at 40 degrees? KNO3, I find the KNO3 line. I find 40 degrees. And the answer KNO3, 40 degrees. The answer is less than 70, but probably above 65. So I'm going to say 66. You might have said 65, 66, 67. Because this is 60 and this is 70, there is some estimation involved. So I'm going to pick a number and say it is 76 grams can be dissolved at 40 degrees. Next question. NaNO3, how many grams to make a saturated solution at 10 degrees? NaNO3, find the NaNO3 line, find 10 degrees, go up to the line. It's very close to being 80, like 79 would be acceptable, 80 would be acceptable. So 79 or 80 grams can be dissolved at 10 degrees. At what temperature, 100 grams of water, would you need to dissolve 140 grams? So in the previous two, I gave you temperature and asked you for grams. In this one, I'm giving you the grams and asking you at what temperature could you dissolve that much, exactly that much. So my substance is KNO3, and I have dissolved 140 grams. So I follow 140 grams over to the KNO3 line, and it pretty much crosses that KNO3 line at 70, maybe 71 degrees. I'm going to call it 70. So at 70 degrees, I could dissolve exactly 140 grams of KNO3. How many grams of NH4Cl can be dissolved in 200 grams of water at 70 degrees? Well, this graph is for 100 grams of water. Do I need a whole new graph if I say 200 grams of water? Well, no, I don't. If I know how much can be dissolved at 100 grams, well, how much can be dissolved in 200 grams? Twice as much. So, NH4Cl, 70 degrees. Here's my NH4Cl. here's my 70 degrees. So 60, maybe 61 grams can be dissolved in 100 grams of water. If I instead want to make a solution that's 200 grams of water, I would simply double that and say 120, 121, 122 in 200 grams of water. Next question, which substance is least soluble at 30 degrees? The one that is least soluble is the one that has the fewest grams dissolved at that particular temperature. And our choices are going to be NaNO3. Okay, so I can dissolve about that much NaNO3. HCl. 95. Oh, I can only dissolve about maybe 67 of HCl, so it's not NaNO3. KCl. Where's KCl? Go down to the KCl line. Well, I can only dissolve about 37-ish grams of that, so it's not the first two. Is it KCl? Well, I have one more to look at. The fourth one is SO2. Well, SO2 at 30 degrees, I can only dissolve about 8 grams. So the one that's least soluble at 30 degrees is SO2. Which substance is most soluble? So that's the one that I would have the most grams in solution at 30 degrees. My choices are, again, sodium nitrate, HCl, KCl, and SO2. Well, SO2 is not the most. I can only dissolve 8. KCl is not the most. I can only dissolve about 37. HCl is not the most. I can only dissolve about 67. Sodium nitrate is the most soluble. I can dissolve about 95. Next question, which substance's solubility is most dependent on temperature? That means which one changes the most as your temperature changes. Okay, my choices are sodium nitrate, potassium nitrate, HCl, and sodium chloride. Which one changes the most with temperature? Well, the one that changes the most has the steepest rise or fall. So KNO3 is definitely a steeper curve than NaNO3. NaCl is almost flat. It changes very little with temperature, from 35 grams at 0 to about 39 grams at 100. HCl is declining, so it's kind of going the opposite, but again, it is not declining anywhere near as steeply as this one is inclining. So the one that is most dependent on temperature, the one that changes the most, from about maybe 13 grams at 0 degrees up to 150 grams at 72 degrees, that is a very significant change as the temperature changes. Next question. Why does the line for NH3 go in a direction opposite most of the other lines? Most of the lines you can see are increasing with increasing temperature, but some are decreasing. In a previous video, we talked about the effect of temperature on solubility and said that most solids increase in solubility as the temperature goes up. However, most gases decrease in solubility. So ammonia is a gas. Ammonium chloride is a solid. So it increases in solubility. The gas ammonia decreases in solubility as temperature goes up. Okay, next question involves what kind of solution do I have? Is it saturated, unsaturated, or supersaturated? So in this case, KCl, 90 degrees, 70 grams. So I find the KCl line. I look at 90 degrees. Oops. KCl, 90 degrees, and I have 70 grams in solution. Well, I should only be able to dissolve about 55, but I have dissolved about 70. I have more in solution than I should have. So the line represents a saturated solution. The solution I have described is above the line. There is more in solution, too much in solution. So it is supersaturated. Number 10. Now I'm saying KNO3, 50 grams, 30 degrees. What kind of solution is it? So KNO3, 50 grams, 30 degrees. Now we could argue, well, is it 50 grams or is it 49 grams? But basically it is on or very, very close to the line. So that solution essentially falls on the line. So I would call it a saturated solution. Next question. Level of saturation. Now I'm talking KNO3, 50 grams, 70 degrees. Oops, I think I skipped something here. My bad. This is question number 11. Okay, so question number 9. What is the saturation level if I have KCl, 90 degrees, 70 grams? KCl, 90 degrees, 70 grams. I should be able to dissolve 55. I have dissolved 70. I've dissolved more than I should be able to. So the solution falls above the KCl line, so it is supersaturated. Similar question. Now it's KNO3, 50 grams, 30 degrees C. KNO3, 50 grams, 30 degrees C. Now, we could probably argue, well, is it 49 grams? Is it 50 grams? But basically that point essentially falls on the line for KNO3. So if it falls on the line, how much can I dissolve to make a saturated solution? I would say that that solution is saturated. And the next question. Now we've got 50 grams KNO3, but now the temperature is 70 degrees. KNO3, 70 degrees, 50 grams. Well, I am able to dissolve about 140 grams of KNO3 at that temperature. I have only dissolved 50, so that solution definitely falls below the KNO3 line. So that represents an unsaturated solution. Last question. I make a saturated solution of KClO3 at 90 degrees. I then cool the solution to 70 degrees. So the question is, how many grams of solid KClO3 should fall to the bottom when I reduce that temperature from 90 to 70, assuming the solution does not supersaturate? So this one's a little bit more complicated. What I have to do is look at what's the solubility at 90, what's the solubility at 70. So KClO3, I made the solution at 90 degrees. I was able to dissolve 50 grams. If I cool the solution to 70, I should only be able to dissolve about 35 grams. So if it does not supersaturate, that excess 15 grams, 50 minus 35, should fall to the bottom of the solution as solid crystals. Okay, so hopefully you've paid attention and understood how to answer these different types of questions. Tomorrow's assignment will be to use the solubility curve and answer a variety of questions. The assignment will not be multiple choice, so you'll have to actually write a number. So realize there is some estimation involved. So if I said, what's the solubility of NH4Cl at 80 degrees? Okay, well, here's a line for 60, here's a line for 70. Well, it's definitely between 60 and 70. And it's kind of about close to halfway. I'd say that's a little bit more than halfway. So I would probably call it 66 grams. Well, if you said 65, 66, 67, maybe even 68, we should all agree that it's probably above half, but it's not real close to 70. So 66, 67, maybe 68 would be acceptable answers.